Welcome, Wildcats. Today we're going to begin looking at linear quadratic systems. That is 3.1a is what we're going to call it, but this is where Algebra 2 starts to get a little confusing, because if you're using your textbook stuff, this is actually from section 5.2 in your textbook. So I'm going to call it 3.1, but if you're using textbook pullouts, keep in mind that this is actually from chapter 5.2. So let's go ahead and take a look at 3.1a, linear quadratic systems. So there are 5 steps to solving linear quadratic systems graphically, and like we've started everything else, that's what we're going to start with. So for our first step, all you need to do is graph your linear equation, graph your quadratic equation. After you've graphed them, figure out what 2 spots they intersect at. Where do they cross? Step 3, figure out what those spots are called. Step 4, and then profit. So let's go ahead and take a look at a couple of examples of what this looks like. So our examples are going to be on Desmos. So here is our Desmos graphs, and for example 1, the linear equation that I've chosen to go with is 2x plus y equals 6. 2x plus y equals 6. So what we do is we go ahead and graph that. I don't know why it's graphing both of them at the same time, but we're going to go ahead and graph that. And then we're also going to graph the quadratic, the x minus 3 squared minus 3. And that looks like this. And if we zoom out a little bit, we can see that there are indeed 2 places where this crosses. They cross right here, and they cross right there. So with these 2 crossing locations, we have discovered both places that they cross, and now we just need the names of those. So the solutions to this equation are 0, 6 and 4, negative 2. So if we want to write those down, that's going to look like this. We have 0, 6 and 4, negative 2. Okay, apparently I don't get to write that big. We have 0, 6 and 4, negative 2. Alright, so that is our first example. We had our equation. It had 2 spots where it intersected, and we just found the names of those 2 spots. So example 1, done. Let's take a look though at example 2. So our first equation is 2x plus 3y equals 3, and that is our linear equation. When we graph it, it looks like this. And our second equation is negative y minus the quantity x plus 3 squared equals negative 2. Now we've never seen anything written this way, so it can look kind of confusing, but just remember that we're using Desmos to graph these problems. We don't really need to know what the graph looks like by looking at the formula. All we need to be able to do is press graph. And we need to find where these intersect. Well, you can see that your linear graph is up above this parabola, and the parabola opens down. So because of that, these do not intersect at all. So for example 2, we call this no solutions. It is possible for a straight line to never intersect a parabola. I would say example 1 is the most common that you're going to see, where it crosses twice. Example 2 is the next most common, where it doesn't cross at all. So think for a second, what might example 3 look like? We've got the case where it crosses twice, the case where it doesn't cross at all. But if you think about it, you can end up with a case where, stop it, your linear line looks like this, y minus 4x equals negative 8, and your quadratic looks like this, y equals x squared minus 4, and we can see that they come very, very close over here. But if we zoom in, it's very difficult to see because of how close they get to each other that they do actually touch right here at 2, 0. So this is a case of a line and a parabola meeting at exactly one point. Later on, we're going to learn that that's called a tangent point. And in a case where a line and a parabola meet at a tangent, it has exactly one solution. In this case, 2, 0. Oh, Wildcats? That's everything that you need for 3.1a in your notes. So hopefully that gets you a good start on your Unit 3.1 HRW assignment. If you need anything, you guys know that you can find me solving those problems on YouTube. And good luck.